Okay, let's bring everything together and look at how you will use the reward model in the reinforcement learning process to update the LLM weights and produce a human-aligned model. Remember, you want to start with a model that already has good performance on your task of interest, so you'll work to align an instruction fine-tuned LLM. First, you'll pass a prompt from your prompt dataset, in this case, a dog is, to the instruct LLM, which then generates a completion, in this case, a furry animal. Next, you send this completion and the original prompt to the reward model as a prompt completion pair. The reward model evaluates the pair based on the human feedback it was trained on and returns a reward value. A higher value, such as 0.24 shown here, represents a more aligned response. A less aligned response would receive a lower value, such as negative 0.53. You'll then pass this reward value for the prompt completion pair to the reinforcement learning algorithm to update the weights of the LLM and move it towards generating more aligned, higher reward responses. Let's call this intermediate version of the model the RL updated LLM. This series of steps together forms a single iteration of the Rlhf process. These iterations continue for a given number of epochs, similar to other types of fine-tuning. Here you can see that the completion generated by the RL updated LLM receives a higher reward score, indicating that the updates to weights have resulted in a more aligned completion. If the process is working well, you'll see the reward improving after each iteration as the model produces text that is increasingly aligned with human preferences. You will continue this iterative process until your model is aligned based on some evaluation criteria. For example, reaching a threshold value for the helpfulness you defined. You can also define a maximum number of steps, for example, 20,000, as the stopping criteria. At this point, let's refer to the fine-tuned model as the human-aligned LLM. One detail we haven't discussed yet is the exact nature of the reinforcement learning algorithm. This is the algorithm that takes the output of the reward model and uses it to update the LLM model weights so that the reward score increases over time. There are several different algorithms that you can use for this part of the Rlhf process. A popular choice is proximal policy optimization, or PPO for short. PPO is a pretty complicated algorithm, and you don't have to be familiar with all of the details to be able to make use of it. However, it can be a tricky algorithm to implement, and understanding its inner workings in more detail can help you troubleshoot if you're having problems getting it to work. To explain how the PPO algorithm works in more detail, I invited my AWS colleague EK to give you a deeper dive on the technical details. This next video is optional, and you should feel free to skip it and move on to the reward hacking video. You won't need the information here to complete the quizzes or this week's lab. However, I encourage you to check out the details, as Rlhf is becoming increasingly important to ensure that LLMs behave in a safe and aligned manner in deployment.